नमस्ते बेटियों, खुश रहिए। I JVWU Muskan Kumari from the Department of Science and Technology, and I'm working here as assistant professor in Vidyapeeth University, and I'm the faculty of education and mathematics. Okay, so today's your session name is basic introduction towards the distributed computing, and this the course name is your distributed computing and parallel distributed computing. The combination of this parallel and distributed combination, isn't it? And this is just course of the program name is intellectual semester. Okay, so today I just want to discuss the first session. Yeah, that's known as the basic introduction to the distributed computing. So now I just want to share the word files which is created by me to make you easy understanding regarding this ones. Okay, so just wait for 1 minute. I am sharing that. Yes, this one. So this files. Okay, so here you can see that this is the program in this subject or course name is running under the program on the second semester, and course name is parallel and distributed computing, and in this I am just going to take the session name. That session name is introduction to the distributed computing. Clear? So now, basic introduction to the distributed computing. Firstly, we want to discuss regarding the what is the distributed meaning of distributed and the meaning of computing, isn't it? Computing means what? That's you are calculating some things, by using the logical and anything, and just to find out some resultant output. Clear? So, and distributed computing is what? Distributed computing is means there are different locations. You are distributing some things in different places. Clear? So, distributed computing is basically like what? There is a network. In network, suppose you have some situated, you have placed many computers, and the load of each computers are will be equals just by using the load balancing concept. Okay, so distributed system also known as the distributed computing, and it is a system with the multiple components located on the different machines, multiple components located in different machines, and that multiple components or the machines should be or will be communicated with each other in the order to appear as a single coherent system to the inputs. Isn't it? The meaning of this means I just want to describe. Suppose there is a network area. In that network area, you have placed multiple components. That components name will be like the node A, node B, and that will be the system A, system B, system C. This is the naming of the systems, isn't it? And you are just connected all the components of each systems towards each other, and when you will work on one system, the same work will be done by multiple systems which is situated in that network place, mm, and they are binding with each other. And so this is just showing that the load is balancing. Load here is balancing in each systems, and they will appear in the single work at the same time here. It means the single coherent systems, and it represents the user in the same. For example, you can see that the whenever you want to take an examination of government examination, isn't it? When you have seen any government examination or the MCAT examination, any organizational examination, government examination, that you will see that whenever the users are the sense applicants sit for their doing the examination, the interface of computer is same similar to all the students in that networks in that classroom. So this is the same thing that coherent system is appearing at that applicants to the same. Clear. So the machine that are a part of the distributed system may be computers or the physical server, and a virtual machine, container, or any other nodes that connect to the networks. Okay. So these all will come, and memory and There are required some messages for communication. So there are two types of the distributed system function. Distributed system, this is well known to you, that what is the distributed system? Distributed system is that in a network you can place multiple nodes or the systems or the server, and that all servers are coherent to each other and working the same things at the same time, and it appears to the user. Okay, what appears to the user? The same things appear to the user, isn't it, in users? So now we will discuss the function. What are the functions of the distributed computing? Clear? So each machine works towards a goal, and individual views result on one cohesive unity. Suppose all the users had their predefined goals that they have to achieve that goals. So each machine works towards the common goal. They just machine try to work towards the goal, whatever the goal is decided by the users, and they are just try to working and find out to that goal, isn't it? And each machine has its own end user, and the distributed system facilitates sharing of the resources, communication services. This is well known that whenever the distributed system is happening, then the resources must be in the sharing form, isn't it? In sharing appearance. So each machine has its own user, and distributed system facilitates sharing resources and the communication services. Although the distributed system can sometimes be obscure, they usually have three primary characteristics. First is all components can run concurrently. Yes, it's right that all components will run in the parallelly form, or concurrently form. There is no global clock. No global clock is on a particular system, and all components fail independently of each other. Suppose if one system gets failed, then it doesn't affect to the another systems which are connected with that ones in the same network area. So now benefits and challenges of the distributed components. Uh, Now benefits and challenge of distributed system. There are three reasons that firms generally decide to implement the distributed system. First is the horizontally scalability. Second is the reliability. Third one is the performance. So what says horizontal scalability? Just wait for a minute. I'm just explaining these ones. That horizontal scalability means what? What do you think about the horizontal scalability? Scalability is just like it. You can scalable that things in the extended form, isn't it? There is some things which is in the fixed form, and you are just want to scalable that things, and you want to extend that things for the more further working. So that is known as the scalability, and this is the horizontal scalability is what? Since computing happens independently on each node, this is clear to you that each node or each systems are working independently to the other other. It is easy and it generally inexpensive to add additional nodes and functionality are necessary. So, if each nodes will work independently to another's, then it is very inexpensive in nature, and this is very easy to implementations or add the other nodes or more nodes in that network area. Okay, reliability. Reliability. Most distributed systems are fault tolerant, and they are can be made up of hundred of the nodes that work together. If suppose you are binding the hundred of the systems in one and gathering to perform the same task, so the all system must be reliable in working. Isn't it? The system generally doesn't experience any disruptions if single machine fails. Suppose one machine get fails, then it doesn't affect the another machines. It doesn't affect the reliability of other machines, isn't it? That all the contents of the other machine which are displaying to show the outputs as well. Performance. Now, what is the performance? What are the performance factor? What affects to the distributed system? So, distributed system are extremely efficient because workload can be broken up and sent to the multiple system. I have earlier told this points that in distributed system in the network, all systems and nodes are situated in that different places in a particular network, and the load of all networks are sharing to each other. So the performance is better, and the working performance is very costly, isn't it? So this is that things. Distributed system are not without challenge. Complex architectural design and constructions is also will be complex, and debugging process is also will be, very fastly, because load is balanced to each systems, and that are required to create an effective distributed system and overview. Now, there are more challenges you encounter, including like the scheduling factors, latency factors, observability. So, what is the scheduling? Scheduling a distributed system has to decide that which job needs to run. Suppose there is a job which didn't need too much at that time to running on the particular systems, but there are some high priority jobs which has required to run at that particular time. So, what distributed system decides that which job they will firstly run to the system, and when they should run, and where they should be run, isn't it? So cellulars ultimately have limitations, leading to an underutilized hardware and predictable runtime. So latency is what? The more widely your system is distributed, the more latency you can experience with the communication. How much systems are distributed in networks? How many systems are distributed in the network? So the more latency you will be gain as experience, right? For the during the communication of all the systems, and this often leads to the teams making trade-off between the availability and also the consistency and the latency. Now, observability. Gathering, processing, presenting, and monitoring hardware uses, how much hardware is required in that particular networks of all the systems which is situated in that network. So, gathering of all resources and processing of the that all resources, presenting and monitoring hardware uses metrics for the large cluster. Cluster is what? There is a network in which you are situated multiple systems, and that systems are situated like a and available in that network like the distributed form. So that is the formation of the cluster, that isn't it? So this is showing that all the gathering, presenting, and processing and monitoring of all that systems for the large cluster is the significant challenge, isn't it? So this is the basic forms of the your distributed computing and basic introduction part of your distributed computing. Now in the next session I will discuss about the what is the distributed computing this, where you can use this distributed computing, and what are the various applications in which you can use these ones, isn't it? So in next session we will discuss these all the things. Again, I just want to conclude this in one argument that this is the basic distributed computing definitions, and there are two distributed computing concerns which is I have already described to you. First is what? Each machines which are in the distributed form in the particular network have their decided pre-decided goals to achieve for the end users to show their results in the cohesion units. Second one, each machine has its own end users, and distributed unit system facilitates sharing the resources. Clear? And the benefits and challenges of distributed system, like in the horizontally, or you can say the scalability, in regarding the scalability, reliability, and performance. And the challenges is in the in which factors, challenges effects of which factors, the scheduling, latency, and the observability. So this session is just almost completed, and we will discuss the next session. I just refer some thing to you to read this topics in beauty form. You should read this by using the links for website, story about site. Here, this is the online site for accessing the documents, and you can also read the master research papers, because you are the students of the MTech, so you have to read some research paper regarding the distributed computing in the cohesive part, and also into the distributed computing. Okay, in the context of the latency, okay, and scheduling also. So read out this all the things, and also read by this the standard book to the introduction to the book was the district. Okay, thank you.